Hi everybody, and welcome to our next video of Chapter 2. In this video we are going to be talking about rearranging equations into a form, a special format, which is called slope-intercept form. So the idea here is not that we're solving equations and getting a number as our answer, but just taking an equation and rewriting it so that all the same pieces of the equation are there. They're just maybe in a different arrangement than they were before. When we rearrange an equation so that the y is by itself, we say that the equation is written in slope-intercept form. A lot of times students remember y equals mx plus b from middle school, and that's a helpful form of an equation for when we're graphing lines. So today we're going to try to take equations that don't look like this and rearrange them so that they will look like this. For example, your final answers in these problems should look something like this. Y equals negative 1/2 x minus 7. The y should be by itself. That's the first important piece here. The term that has the x should be first. And the constant term, which does not have an x, should be last. As soon as you have that, you know that you have your equation in slope-intercept form. Now we're going to use the same ideas here as we used when we were solving equations, only instead of solving, where we're going to get an answer like x equals 2, we're going to end up with a new equation as our answer. Let's take a look at an example. So I'm still going to start by drawing a vertical line through my equal sign, and my goal here is going to be to get the y by itself. The y is right here. That's my goal. In order to get y by itself, the first thing I'm going to do is subtract 3x from both sides of this equation. Now, when I do that, the 3x on the left-hand side cancels, and I just have 2y. On the right-hand side, the 8 and the negative 3x are not like terms, so they can't be combined. What we're going to do is just write both of those terms down separately, but we're going to put them in a very specific order. We want the term with the x first, so I'm going to write the negative 3x first, and then I'm going to drop down the positive 8. You'll notice I added a plus sign there because this is a positive 8. Now, y is almost by itself, but we do have one more thing we need to do. Right now, y is being multiplied by 2. So in order to get rid of the 2, we need to divide by 2 on both sides. Now you'll notice I'm dividing every individual term by 2. It's really important to remember that we're dividing everybody in this equation, not just the y or one of the other terms. On the left-hand side, the 2's cancel, and you get y. On the right-hand side, I would ask myself, hey, does negative 3 over 2 simplify nicely? And the answer is no. Negative 3 does not divide nicely by 2. I would get a decimal. So I'm just going to leave that as negative 3 over 2 and then drop down the x. So this just drops down. And then I would ask myself, okay, well, does 8 divide nicely by 2? And the answer to that is yes, 8 does divide nicely by 2. 8 divided by 2 would be 4. And now that I have y by itself, the x term is first, and the number is at the end, I know that I'm done. That's your answer. Let's take a look at number 2. So in number 2, again, we're trying to get y by itself. I'm going to draw my line, and the first thing I'm going to do is add the 2x to both sides so that the 2x will move to the other side. So I'm going to drop down the 3y because the negative 2x and the positive 2x will cancel. Just like in the previous problem, the 6 and the 2x are not like terms, so I can't combine them. Instead, I'm going to write them separately, but I'm going to make sure that the 2x goes first and the number, which is a positive 6, so I'm adding in a plus sign there, goes second. Now I need to get the y by itself, so I'm going to divide everybody by 3. The 3's cancel on the left-hand side, so all I have left is a y. On the right-hand side, I'm going to ask myself, does 2 divide nicely by 3? The answer is no, I would get a decimal, so I'm just going to write down 2 over 3, and I'm going to drop down the x. And then I'm going to ask myself, does 6 divide nicely by 3? And the answer is it does. 6 divided by 3 is 2. So I would write down the plus 2. And that would be my final answer. Let's take a look at another example. Let's skip number 3 for right now, and let's do example 4 together. So in example 4, it's a little bit of a different problem. We're still trying to get y by itself. To do that, it's going to look a little bit different than the first two problems. The first thing I'm going to do here is I'm going to add the 3x to both sides. Now the 3x's on the left-hand side are going to cancel, and I'm just going to drop down the 4y and the minus 7. Now 0, even though it's a number, 0 plus 3x would just be 3x, because 0 plus anything is just that thing. Now I still need to get y by itself, so it looks like I'm going to need to add 7 on both sides in order to make that happen. I'm going to save dividing for my last step always. I'm going to drop down the 4y, and the 7's are going to cancel on the left. On the right-hand side, the 3x and the 7 are not like terms. That's why I did not write the 7 below the 3x. I wrote it next to there, because those are not like terms. You can't combine them. So what I'm going to do is just drop them both down. So I'm going to drop down the 3x first, and then the plus 7, because I can't combine them. Finally, I'm going to divide everything by 4. So on the left-hand side, the 4's are going to cancel, which means all I have left is a y. On the right-hand side, I'm going to ask myself, does 3 divided by 4 simplify nicely? And the answer is no. 3 over 4 is a decimal. So I would just write 3 over 4x. And I would then ask myself, does 7 over 4 simplify nicely? And the answer is again, no, it doesn't. It makes a decimal. So I would just copy down 7 over 4, and that would be my final answer. Let's do one more problem together in this video, and maybe we'll do some more examples in class tomorrow if we need to get some extra help. So for number 5, again, my goal is to get y by itself. What makes this problem different than the other ones is that there is a term that has a y on the right side and a term that has a y on the left side. So the first thing I'm going to do is get all the y's together on one side. To make that happen, I'm going to subtract 2y on both sides. Now on the right-hand side, the 2y's cancel. On the left-hand side, the like terms, 4y minus 2y, simplify. So I would get 2y. 4 minus 2 is 2. Everything else is just going to drop down. The 3x and the minus 7, the 7x and the plus 3. Now I need to get all of the y's by themselves. So it looks like I'm going to need to subtract 3x on both sides. So that means that the 3x's are going to cancel on the left, and I'm just going to drop down the 2y minus 7. On the right side, I can combine the 7x minus the 3x. 7 minus 3 is 4, so I have 4x, and I'm going to drop down the 3. Next, I'm going to need to get rid of that 7. So I'm going to add 7 on both sides. Now when I do that, I get the 7's cancel on the left, so I just have 2y equals, now I'm going to combine the 3 and the 7. 3 plus 7 is 10, but I'm going to keep the 4x first. It's really important that the term with x is first here. And then I'm going to write plus 10. And finally, I'm going to divide everything by 2. So I'm going to get y equals 4 divided by 2 simplifies nicely. 4 divided by 2 is 2, and I'm going to drop down the x. And 10 divided by 2 also simplifies nicely. 10 divided by 2 is 5. So I'm going to write a plus 5, and that would be my final answer. Okay, thank you guys so much for watching. We are definitely going to practice this tomorrow in class. Have a great afternoon.